Hello Year 10, welcome to Lesson 4 of Coasts. For this lesson you will need pen, paper, pencil and your fact book, and this lesson is all about coastal management. Your first activity is our quickfire round, so pause your video here, study the 5 questions which are from lessons 1, 2 and 3 and have a go at all of them. Good luck! The natural coastal processes change coastlines, affecting people. Decisions need to be made whether to protect, hold the line, or leave the coastlines to the forces of the sea, so do nothing. Decision makers have to weigh the value and importance of the stretch of coast against the cost of building the defences. So in this lesson, we're going to investigate this decision-making process. Hold the line, hard and soft engineering, is used to keep the coastline intact. And do nothing is allowing coastal processes and erosion to occur despite any of the losses. There are 2 categories for coastal management, or holding the line. Hard engineering, which is usually more expensive and involves dramatic physical structures and changes. Sea walls and groins are types of this hard engineering strategy. Soft engineering usually involves trying to be more holistic, working closely with nature, and is usually cheaper. So this could include beach replenishment. There are many different strategies for each of these different categories. Coastal engineers, councils, residents and the Environment Agency work together to analyse a coastline, determine the risk and the costs of not protecting it, and calculate whether the benefits outweigh those costs. This is based on social, economic and environmental value of the location. They need to consider which approach is sustainable. However, defence decisions at one location will have an impact further down the coast, for better or for worse, which also needs to be considered. Pause the video here and make a copy of the 3 different definitions on this screen. Intertidal zones are important estuarine landscapes. They contain many tidal creeks, salt marshes and mud banks. They are intertidal because these landscapes are exposed at low tide, but at high tide they can store huge quantities of water. So this is the intertidal zone, and it acts as a natural buffer during storms, soaking up wave energy during a storm surge before the waves can reach more valuable land further inland. So there is a real need for managed realignment of these areas. Intertidal zones are much narrower in the UK than they used to be. And this is because many salt marshes were reclaimed in the past to create new farmland. Old earth embankments have kept the sea off these low-lying fields for centuries. Some salt marshes are being eroded by the sea. This is a particular problem along the Essex and Thames Gateway coastlines, where the land is subsiding, so sea levels are rising faster than anywhere else in the UK. Managed realignment can be used to create new intertidal zones of salt marshes. The process begins by punching holes through the old earth embankments. The invading seawater moves slowly across the land at high tide. As it flows in, it deposits sand and silt and mud. As it flows out, it creates tidal creeks, and this process recreates natural mudflats and salt marshes, which will store water and act as a buffer to erosion in future floods. Pause the video here, maybe rewind if you need to, and make a list of reasons why intertidal zones are narrower than they used to be. Listen out for 2 of those ideas. So there are several different hard engineering strategies, and 4 of them are here on the screen. The first one is groins. These help to reduce longshore drift because they trap the material. Wooden groins cost about £100,000 each, and rock groins cost £125,000 each. Wooden groins, though, have a short lifespan and they need to be replaced every 10 to 15 years. We also need to constantly maintain them, and this also costs about £1,000 per year per groin. Sea walls can be straight or curved, and they are usually made of concrete. They are built to reflect the wave's energy, so the wave crashes into them and then is released back to the sea. And this means they protect the land behind. They can be considered quite ugly, unattractive, and they are very expensive, usually £5,000 to £10,000 per metre. Rock armour, also known as riprap, is often considered to be more natural looking, as they are just large rocks, large boulders placed along the coastline. They break up the wave energy again, but they also trap sediment, so this means they keep the beaches and the cliffs intact. They cost £1,000 to £3,000 per metre. But if it's large scale, it can then be very expensive. The image on the very first screen is of Haysborough, and rock armour is used there, and it costs about £1 million. The rock also has to be transported a really long distance. Gabions, small rocks, are encased in wire cages, and they also absorb wave energy. They are usually placed against the bottom of cliffs and on beaches. They cost about £1,000 per metre. They tend to be considered quite unattractive, and the wire mesh can erode and break up and therefore can become very dangerous and is a risk to the public. Pause the video here. Choose one of these 4 strategies and explain the sustainability of the scheme. So you're thinking about its lifespan, but you're also thinking about social and economic benefits and disadvantages to the scheme as well. See if you can justify your choices. So there are a few different soft engineering strategies, and 2 of them on the screen. Beach replenishment maintains the size of the beach, which is good at absorbing wave energy and is considered to be attractive and natural. It costs about £2,000 per metre. However, beach replenishment has to be done frequently, as the material washes away and storms destroy the beach. So actually this costs quite a lot in the long term. Material also has to be dredged, taken away from other places. Haysborough, the image on the first screen, also uses beach replenishment, and the beach replenishment there cost about £8 million. Managed retreat is basically do nothing. Nature is allowed to take its course, and less valuable land is allowed to flood to save other areas. This can lead to the creation of salt marshes and mudflats. However, often valuable farmland is lost, and this also requires compensation in terms of money to be paid to the landowner. Pause the video here. Choose one strategy from above and try to explain its sustainability. Remember to consider both the social and economic benefits and disadvantages. Justify your decisions. As we have seen in previous lessons, the areas of Norfolk and Yorkshire are the fastest eroding areas in the UK, at an average of 2 metres per year. Mappleton is a village in Yorkshire on the Holderness coastline, and it is losing 2 metres of land every year. The main road is just 50 metres from the cliff edge. Mappleton is built on soft glacial till cliffs. The area faces strong prevailing winds that lead to longshore drift, moving material from north to south. There are 50 properties in the village and approximately 360 people live there. It's also very popular with tourism, and there is much rich, fertile agricultural land. The problem though, in the past, around 30 properties were at risk of being flooded or collapsing into the sea if the cliffs failed. The area was eroding at a rate of 7 to 10 metres per year, and the important road B1242 was collapsing into the sea. So back in 1991, hard and soft engineering solutions were introduced, costing £2 million with rock groins, granite rock armour for the cliff base and cliff stabilisation. The defences are maintained and reviewed each year, and further groins have been added over time. The groins trap the sand and build up the beach at Mappleton. A wider beach means that waves use up energy as they break on the beach and therefore reach the cliff less frequently. This protects the cliff from erosional processes. So the great news is the properties are now protected. The cliffs at Mappleton are stabilised and erosion has decreased. Longshore drift has been reduced, trapping sediment at Mappleton to build up the beaches. However, the coast to the south is now suffering. Beach material, which is now trapped at Mappleton, used to travel south. So this has reduced the size of the beach in the south, which has increased the erosion rates from 1.7 metres to 3.3 metres per year, with some areas losing 10 metres a year. Farmers have also lost a lot of their valuable farmland, and some farms have disappeared altogether. Some people believe the sea defences at Mappleton have made the situation even worse. So pause the video here. Decide from the 3 options below which is best for the future of this coastline. A, do nothing. Leave Mappleton as it is. Do not spend any more money on the coastal defences and allow nature to take its course. B, invest in new hard engineering, so rock armour and rock groins. Or C, invest in a combination of soft and hard engineering between Mappleton and further south. Beach replenishment, a sea wall, and extending the rock groins. Make sure you consider the advantages and disadvantages of these different ideas. Also try to think about sustainability. And whatever decisions you make, try to justify them. So try to explain why you think it's a good idea or a bad idea. Well done, Year 10. You've now reached the end of Lesson 4, all about coastal management. Do remember to go back over this lesson and pause it as many times as you need, and do the same with Lessons 1, 2 and 3. You've got 4 facts here that you need to remember, and we will use some of these in our quiz next lesson. Well done.